So guys, welcome to the lecture 12 part 1 and topic is a tree. So today we discuss what is a tree and what is the types of tree, what is the properties of tree. We discuss everything related to the tree. So first we discuss what is a tree. So tree is a non-linear data structure that represent data in a hierarchical form. It consists node connected by the edges without forming any cycle. So tree contain root. So what is the root? Root is a topmost node of the tree. And what is a child? Child is a node that are direct descent of a node. What is a parent? So parents is a node that are the child node. So parents is a basically a node that has child nodes. Leaf node is a basically that node with no children. Age is the connection between two nodes. Height is the length of the longest path from the root to leaf. Depth is a basically distance from the root to the given node. And level is a depth plus 1. Root level is a 1 because given tree it's have root value, so roots also level 1. So we just plus for the root. Now we discuss properties of tree. So if there are n node in a tree, then there will be the n minus edges. If there are n nodes in a tree, then there will be a n minus 1 edges. There is exactly one path between any two nodes. Trees are acyclic and connected. Now we discuss the types of tree. So first is a general tree. So a tree where any node can have any number of children. So this is the general tree. Now come to the second one. Second one is a binary tree. So each node has at most two children, left and right side, and this one also have some types. So full binary tree means every node has 0 or 2 children. Complete binary tree, all level are completely filled except possibly the last, which is a field from the left to right side. Perfect binary tree means all the level are completely filled, and skew tree all the nodes are on the one side, left or right. Now come to the third types. So third one is a BST. BST means binary search tree. So a binary search tree basically left subtree has a smaller value than the nodes. So a binary tree where left subtree has smaller values than the nodes and right subtree has the larger value than the nodes. In order traversal of BST gives sorted order. Now come to the fourth one, and fourth one is a AVL tree. AVL is a basically self-balancing BST, binary search tree. Difference in height of left and right subtree is at most 1. Now come to the fifth one, and fifth one is a red black tree. So this is a basically self-balancing BST with color properties to maintain balance. And come to the sixth one and sixth one and come to the next one. Next one is a an array tree. So this is a basically each node can have the at most n children. And now come to the last one. Last one is a heap tree. So a complete binary tree that follow heap properties. So this contain two properties. First is a max heap. Max heap is a basically parents is a greater or equal to the children, and min heap basically parents is a less than or equal to the children. So this is our types of the heap tree. Now we are discuss how to representation of tree. So here you can see the node structure. So first we declare our data, then we declare our left side, then declare the right side. Then we are taking the value from the user. So just put the value in our data, and initially this left and right side is a null pointer. So come to the tree traversal technique. So we have two traversal technique. First is the DFS and second is a BFS. So first we discuss DFS. So DFS has three types: pre-order, in-order and post-order. So in pre-order basically root, then left, then right, and in order left, root and the right. Now come to the post order. So post order is a basically left, right, then the root. Now come to the second types, and second types is a BFS, breadth first search. So this is a basically label order traversal using queue. Queue is a data structure. So now come to the application of tree. So hierarchical data representation in the tree. So this is the basically example of the file system. Binary search tree for the searching. Expression tree is a expression trees in the compiler. Heap for the priority queue. Trees for the string searches. Now come to the advantage of the tree. So efficient searching and sorting in the BST, binary search tree. Flexible hierarchical representation. So this is the advantage of the tree. So I think this one is clear to everyone. So thank you.